problem I'll be doing is on Laplace transforms. And I kind of created my own problem. Laplace of 1 plus 3t squared plus cosine 4t plus e to the 2t sine of t plus 8 u of t minus 1. Kind of just to show all the different ways you could pretty much do it. A few different ways. So the Laplace of 1, or first of all, you're going to want to break it up into each individual parts of 1 plus the Laplace 3t squared plus Laplace of cosine 4t plus Laplace e to the 2t sine of t plus 8 Laplace of u t minus 1. Could have pulled the 3 out of there too, it doesn't really matter. So Laplace of 1 is just 1 over s plus, pull 3 out right now, t squared is going to be whatever this number up here, factorial over t, or s to the n plus 1, so it's going to be s cubed plus Laplace of cosine, which is going to be s squared plus 16 on the bottom and 4 on top. Actually s over s squared plus 16. And then you're going to have this term, which is going to be a couple steps more than the other ones. It's going to be a sine of t. S is a translation from s to s minus 2. And this is going to be 8. And when the unit step is by itself, the formula is e to the negative whatever t minus whatever that number is, s all over s. So then we're just going to rewrite this one. 3 times 2 factorial. 2 factorial is just 2, so it's going to be 6 over s cubed plus s over s squared plus 16 plus sine of t is 1 over s squared plus 1 from s to s minus 2 plus 8 e to the negative s over s. And that's going to end up looking like, just rewriting this. And for the translation, you're going to plug in s minus 2 for s. So it's going to be s minus 2 squared plus 1 plus 8 e to the negative s over s. So those are a bunch of different Laplace transforms that you could take. Go from the basic one to one with a t to a root or a exponential term, cosine term, and then you have a translation term with a sine function and then a unit step function. So that's a very broad aspect of the Laplace transforms.